Hello friends, you are watching the channel Being Mathematician. Social distancing. Almost we all know the term in recent days. The question is how important to maintain this in this COVID-19 situation. So I'm trying to explain it by the exponential growth formula with brief analysis. So keep tuning with us. Let's see the formula first. X of t equal to x0 into b to the power t, where xt, the function of t, is the number of cases at any time, any given time t. x0 is the number of initial case and small b is the number of people infected by each sick person. It is called growth function, growth factors. So let's see in detail for 14 days of an epidemic. So let x0 be 1. The number of initial case is 1 and b 2, means each sick person infects 2 other people, and we have to calculate the time. We have to calculate the time from 0 to 14 days. So let's see the data. So let's calculate the data from 0 to 14 days. Our formula is function of t, x of t, equal to x0 into b to the power capital T. So when t equal to 0, then x0 is 1 into 2 to the power 0, where b is 2. So that will be 1. When t equal to 2, x of 2 equal to 1 into 2 to the power 2, that will be 4. So when t equal to 3, x of 3 equal to 1 into 2 to the power 3, that will be 8. When x of, in the similar way, x equal to t equal to 10, then x of 10 equal to 1 into 2 to the power 10, that will be 1024. And in the similar way, we can calculate when t equal to 14, that is x of 14 equal to 1 into 2 to the power 14, that will be 16384. So the calculation shows us starting from 1%, and with a growth factor of 2, we obtain more than 16,000 cases in just 14 days. You just imagine, if the growth factor B is greater than 2, then what will be the number of infected cases in 14 days? We have to understand these data graphically to explain it briefly. So let's see the graph of this data. This is the graphical representation of the data. If we observe it carefully, then we see this after 10 days. After 10 days, it shows a great increase of infection, and 14 days it will be near to 17,500. that is, this number is 16,384. So see the initial days, 0 to 10 days, the graph is just increasing. But after 10 days it will be strictly increasing. So let's see the exact COVID-19 infections world data. Now we are starting from 21 January 2020. Days 1, and infections is near to 282. After 10 days, 31 2020, this will be days is 10, and this will be a huge increase of data, that is 7818. And after next 10 days, 80802 2020, the data is days is 30, this is 20, and number of infections 34886. After 10 days, 17th February. After 30 days, the data is 71429. After 10 days, 26th February 2020. After 40 days, it will be 81109. After 10 days, 0603 2020. 50 days, it will be 98192. And after next 10 days, that is 15th March, it will be 60 days, it will be 153517. Let's plot this data in the graph paper. So this is the graphical representation of the actual data from 21 January to 15th March. Let's see from day 1. This is increasing, and this is increasing, and this is the stage 1. And and this will be 50 days. This will be the stage 2, where the number of infections is, the rate of infection is minimized from 30 days to 50 days, this duration. But after 50 days is, oh my god, it will be a strictly increasing character, and it's cross 1.5 lakhs and reach to 153517. Now let's compare the original world data graph with growth factor 2 graph. It is clear then that COVID-19 graph is more dangerous than the graph of growth factor 2. According to China, the growth factor of COVID-19 is greater than 2 and less than 3. So, I think you have realized that in this situation, you have to maintain social distance at any cost to minimize the value of B. So, stay safe, stay at home, and save the world.